Perfect. All right, we're gonna go ahead and get started here. Since the chiming stopped, now it won't be interrupting Chris as he goes if we have some people join us. So I want to thank everybody for joining us today. My name is Ian Bordeaux. I'm the secretary here with NCLUG. Welcome to our third tech talk. Kind of using these as a way of kind of substituting for our conference due to COVID. So thank you guys for joining us today. Today's topic is going to be bringing data to the OpenRoads Designer. So pretty much discussion of different types of project data that can be imported or referenced into OpenRoads Designer, and then how it can be used. Kind of discussing bringing different formats from like Bentley, GEOPAK, InRoads, MX formats, and other sources, including text files, XML, and other files into OpenRoads Designer. Just a couple housekeeping items. Where this is a presentation, so we're going to keep everybody muted. We'll be able to hopefully answer some questions at the end. So we'll definitely let you know when to unmute then. Please save the questions till the end. We'll also note that we're going to be adding this recording to our website, so you're welcome to go back and reference that in the past, but we won't be able to offer any credit for viewing it then, since we're not able to track who is able to view that. Make sure if you are joining us by phone to make sure you email us at NCLUG events so we can give you credit. Make sure you provide your license number and name so we can match that up to your name here when we export the attendees. If you did not register, make sure you go and register the event. We'll keep the event registration open for a little while so that you can register so you get credit for this PDH. And definitely let us know if you don't receive that by the end of the week. Also, make sure you stay to the end. We'll be doing a drawing for a $50 Amazon gift card. Patty will handle that at the end. And with that all handled, Chris, thank you for joining us today, and I'll leave it to you.
Okay, thank you. Can you see my screen? Okay.
We can.
Okay, perfect. So this session, we're going to be discussing bringing data in OpenRoads Designer. This will be something you guys will probably run into, I'm sure, bringing projects forward and such. So we're going to talk about a few different file formats and how to bring those in. We're going to look at bringing in each of these different formats: InRoads files, GEOPAK files, land XML, MX and Genio, 12D, and IFC. And you may or may not run into all of these, but I'm sure you'll run into at least a few of them. So the first one we're going to start with is talk about InRoads and GEOPAK files. And these are from the legacy products, and essentially just bringing this stuff forward. The data file types with regards to InRoads, you have .dtm. These are extensions. The DTM files contain the terrains. ALG files contain the geometry. Your ITL is your template libraries, of course, and your IRD files are would be SS2 roadway designer type files. All of that information can be brought forward into ORD. Similarly, the GEOPAK data file types, same information, just different extensions. The TIN file is our terrain, and I say our GEOPAK. GPK is the geometry, the coordinate geometry database, and then the ITL and IRD files are the same between both products and are SS2 format. So first we'll look at bringing in terrain information. The OpenRoads terrains, what we want to do when we bring in these DTM and TIN files and even the land XML files is we're essentially taking legacy data and turning it into a OpenRoads terrain model. Now, a terrain is a 3D mesh element in a 3D design file. You can import these directly from the files. There are other ways to create those as well, and that's using graphical filters where you search data for graphical data for certain feature definitions and such to generate terrains from those, as well as survey information, point cloud scans, and just regular old graphical element. So any of these types can be generate a terrain inside of OpenRoads Designer. So first we'll look at the basic workflow for importing terrains. And really it's just a matter of making sure that you bring these into a 3D design file. We're going to look at the import file and then some options to control how that file is imported, and then also assigning feature definitions to your terrain. I'm going to be narrating over someone else's presentation, so there may be some minutes or some places where we pause or don't match up, but just bear with me here. So the first thing to do here in OpenRoads Designer is to make sure that you create a 3D design file. So you want to make sure that you have the 3D seed file. And in this case, I'll just call this one existing ground. And then you want to be sure that you're in the OpenRoads modeling workflow. That's to pull down at the upper left. And then on the ribbon, you have various tabs, and we're going to go to the terrain tab, and you see there's several options under the create grouping there. So the one we're going to look at here is creating from a file, and in this case you'll just get a directory there of whatever files you have available, in this case an InRoads DTM. It's just a matter of selecting that, and then you're presented with this dialog box for making various settings to control how that's brought in. And your file options down here on the bottom right is the main place that you're going to be making settings. And there are best practices or options here for you to follow. Of course, your source file units, if it has a GCS or something built into that, it would show you this. Typically unknown is a safe option there if you're not sure what the file units are. And then the next option there will be to set a feature definition. And this is how you want this to be represented in OpenRoads Designer. Basically what feature symbology information do you want it to have? Your triangulation options here, you have terrain only, features only, or both. So doing the terrain only is simply going to use the triangle faces. If you brought in the features along that with that, you could do both. And what it would do is it would combine those faces and the features and do a triangulation on it. So if you want to reproduce exactly what you had before, then terrain only is your best option there. Of course, you can assign a GCS to it if you have a coordinate system that you want to associate with that terrain model. And then again, down in the bottom, you have the option to set the feature definition. So once these settings are made, then it's really just simply a matter of selecting the import button, and it'll process for just a second, depending on the size of your terrain model, and then it'll bring that information in. So here we'll just set a feature definition to whatever's available, existing boundary or existing triangles. And these are going to be feature definitions that need to be set up in your workspace to have available for you to select from. And it's going to tell you in the bottom left there, your import is complete. And then this is what you get when it's completed. And since we selected a feature definition of existing boundary, that's all that's displayed here is the existing boundary. So once it's in here, you have a few options here. It can be manipulated. You can change the symbology. You can change how it appears. You would simply select on that boundary. You do get a heads-up menu when you make a selection there, where you can make various settings. And there you see in the properties dialog on the left, you have an expanded list of the settings. You also have the heads-up balloon there that gives you a little information telling you it's a terrain. The quick properties on the context menu there shows you some various options. So you see how you can kind of modify the display of that particular feature definition with the toggles that are available there at the bottom. You can turn contours on and off. And again, it's just, all this is doing is manipulating how the terrain looks in the file. And again, that's controlled with the feature definition that needs to be pre-configured prior to you bringing in the terrain model. So here, if we were to just turn the brake lines on, you'll see how those were, of course, they were in the DTM that we brought in. So they still show up as source data for that particular DTM. So you see how we can segregate that information out just for viewing purposes, we can turn on the break lines or the spot shots that were embedded in that DTM file. Since we didn't use the import feature option, we just did the import terrain. These guys are not featurized. Now, and this is also unique to InRoads, in that break lines are featurized in that DTM file. Whereas in GEOPAK, they're just break lines or not. They're not featurized like edge of pavements or curbs or ditches or things like that. They just show up as a break line. So again, more options here for changing the display for source features and calculated features. So the source features are what was triangulated to create that terrain, and the calculated features are things that are derived, like contours and triangle. So here it would be easy enough, just since we have it on triangles, on existing boundary, we could simply come in and select a different feature definition entirely, and that would change the display as well. So there we're actually setting a different feature definition on that terrain from existing boundary to existing triangle. So several ways there where you can change how a terrain is viewed or displayed. Very easy to do. The only caveat is that those feature definitions need to be set up prior to, need to be part of your workspace. Now, if you'll notice in the top up here, we also have the options, pull downs for that particular terrain. We still have access to calculated features and source features as well. So we can go up and make manipulations to those a little bit if we like. You'll see there's options there for turning on flow arrows, spot shots, various things like that. And if you actually wanted to, let's say you wanted to modify the contours, how they're displayed, in this particular option, you can change some of the text intervals for the contour labeling, or you can go up to the contour tab and you could change the intervals of the contours there if you like. So just because it's displaying contours, it's going to start out with however that feature definition is set up as a default, but then you can go change those easily if you need a different contour interval for some reason. Easy enough to go in and change that. So now what we're going to do, once that terrain is in has been imported into a file, we can now use that as a reference. But in this case, now what we're going to do is we're going to import a TIN file. So it's very similar, just like the InRoads file was to import the DTM. Now we're essentially doing the same process, but we're using a TIN file. And again, you can assign a GCS to that if you want. Here we're just setting a feature definition, importing a terrain, and we set it to existing boundary. So you see that the import brought in the terrain under your quick properties. You still have access there, just like you did on the other one, to source data and calculated data, where you can make changes to those and control how the terrain is displayed. So now in this case, we're going to use that as a reference. We'll just create a file here called geometry. And in this case, this is going to be a 2D file. So we want to make sure that we switch C files when creating this to create a 2D. And then we'll simply select the terrain, the 3D DGN terrain that we just created and imported, and just attach it here in our 2D file. And now, of course, as we start doing our design, if we need to reference anything for elevation from existing ground, we have that terrain accessible in our 2D design file. In order to actually access that information, you need to make it active. And that's on the heads up menu. Still have the same properties here, but notice that everything's ghosted out. You can still change how the terrain is displayed. You just have to set the symbology overrides there at the bottom of the dialog. So if you change override symbologies to yes, you see now everything is active. So you can manipulate how it's being displayed. And again, turn on and off contours and such. Even though it's a reference file, you're able to have that ability to change the display. You can also assign a different element template to it. The only thing you have to worry about here is changing element templates, how it's displayed. If anything ever changes on that terrain, it's going to revert back to the original feature settings. So if you were to set it to display contours, in this view, but something happened and that terrain was updated, it's going to switch it back to the existing boundary like you see it now. Okay, so the best practices here is to use terrain feature definitions to control your terrains and not necessarily to use the element templates directly, even though you can. Best practice is to use the feature definition. You can overwrite the feature symbology with an element template, but there again, keep in mind that if it regenerates, it's going to come back to its original symbology. There's a note there at the bottom that they're not quite able to bring the feature definitions, and that's referring to the DTM file for InRoads. Again, I mentioned that in their DTM files, all of their break lines are featurized, so it knows an edge of pavement from a back of curb, and so on and so on. And whereas in the 10 file in GEOPAK, a break line is a break line. There's no feature definitions associated with it. So that was bringing in terrains. The next thing that we want to look at is importing geometry. And again, we'll focus initially here just on InRoads and GEOPAK, since they're the most popular civil design packages here in the state. The process is very similar, you'll see. But there's going to be times when you want to, I'm sure you guys are going to run into cases where you might want to migrate a file or a project and bring it into ORD, and you've already got stuff stored in a GPK file. It's very easy to bring that stuff forward. Or if just somebody outside of your company, may pass you a GPK file that you need to import. So a couple things to remember in OpenRoads. The geometry, they're stored as 2D, 3D elements in a 2D or 3D model. They're dynamic and interactive. It's a rules-based approach. which we can add rules. When you import geometry from a GPK file or a ALG file, the rules can be turned on so that it builds those in automatically. And the dynamic dimensioning and the design intent there are kind of also go along with the rules. So it remembers how things are built. So if you were to create a curve with a deflection, you know, in the, say in a GPK file, then when it reads it and brings it in, it's going to store that as a rule, the deflection angle. So it's going to remember how you build that geometry, and that's the rules that it builds on the when you bring it into OpenRoads, and that in turn is what we refer to as design intent. So it tries to remember what you intended when you stored that. And of course, it's dynamic, and you have your drag handles and manipulators there to make graphical modifications if you like. So here, we're going to, again, do the same thing. We're going to import this time geometry. So what we're going to start out with, we're going to have to create a new file. And of course, you're going to want that in your, you know, in a 2D file. So we want to make sure we use a 2DC file. Here, we'll just give it a name, geometry. Let that open up. Appear to be stuck here. Okay, there we go. So now, once in our file, we want to be sure that we're in the OpenRoads modeling workflow. And we'll go to the geometry tab, and there's an option there under the general tools to import and export geometry specifically. So you see there's a few options there for ASCII, for horizontal and vertical. We'll just use the option for geometry. In this case, we're going to use a InRoads ALG file. So it's similar to GEOPAK. It's a coordinate geometry database. Has the alignments in it. And once you select the file, you're going to be presented with this dialog. It's essentially showing you the content of the information that's in that ALG file. So there you can see we have a few, we have a category there for alignments. If we expand that, we're going to see that there are alignments as well as profiles that are stored in this particular file. So here we see under road centerline, we've got two alignments there, one called Mountain Highway, one called Pike Road. And as we expand those horizontal components, we see that there's also profiles associated with those. So instead of picking these all individually, if we just kind of go up to the top of the hierarchy, we can select, and it'll work down through the tree and pick everything. Or we could have picked them individually if we want to just bring one in. Then you have the civil rules toggle there to the left. You can have it build the civil rules or not. It's just up to you. And then, of course, you just select the import. It reads that database and brings in your geometry. So there you can see that we have two alignment. And the one thing that it doesn't do is add the features to it. So here we would simply, the next step would be to go in and go ahead and assign a feature definition to that. You would need to do that for each of those. So in this case, we'll just select an alignment and the geometric baseline feature definition. And likewise, we'd want to do it for the second alignment. Same thing. Just go to the quick properties, select from the feature definition list, the geom baseline. And then the next part of that, we did import profiles with this. So we would want to select that and pop open the profile, the dynamic profile view, and go ahead and set the feature definitions on those as well. And that's just simply a matter of highlighting the profile component. Again, going to the feature definition and selecting from the available list there. In this case, we'll set it to the same as the alignment. And we'll do the same thing for Pike Road. Pop that in the dynamic profile view, just highlight it, go to quick properties and set the feature definition. And now you're in business. So to do the same thing, except for in this case, we'll do it out of a GPK file real quickly. We'll just simply again create a 2D file. Put this in the right directory here. And the steps are the same. So once in the 2D file, just a matter of making sure you're on the geometry tab, going to the import export, pull down and select the GPK file that you want to bring in your geometry from. Just a little bit of difference here because InRoads, you see we have curves and point lists because we store a little more information in the GPK file. We also, in GEOPAK, they don't, profiles are not associated to alignment. So here under profiles, you would get a list of all the profiles available. And you would have to make the selection of which profile to bring into OpenRoads with which alignment. And that's because in OpenRoads Designer, we do associate profiles to specific alignments. So here you'll see we would just pick the appropriate profile to go with the particular alignment. And then it's just a matter of, again, making sure you create the civil rules if you want those, and selecting the import option. And again, you've got the same alignments, just like we did from the ALG file. The workflow is the same here. You would pop open the quick properties and go ahead and set a feature definition for each of those alignments. Likewise, you'd have to also go and do the profiles, since we did import those. Same thing, just pop it in a dynamic profile view, go to quick properties and set the feature definition for that particular alignment. So pretty easy to get geometry brought in from the legacy products, the older versions. Not much to it at all. So the next step would be looking at land XML. So, land XML is a schema that basically is a data transfer schema for all civil products. So any of your Civil 3D or AutoCAD products that you might use, as well as ours, can export and import land XML. So OpenRoads Designer will do that as well. Have a couple options here under the import. Here, when you select the land XML file, you have the definition is utilizing the stored triangulated faces. You have the source, which uses the survey features, break line, voids, and points, and then triangulates that data. Or you can do the source and definition, which utilizes both of the definition and the source and triangulates. So here we'll go to the next one. Best practice here is going to depend on your situation. If you don't want to retriangulate it, then you're going to use the definition method. Otherwise, we recommend, and the default is to use the source and the definition. So that's just going to use both of the pieces of data and retriangulate everything to get the best triangulation. So terrain rules. We also add intelligence by ruling that terrain. In effect, it creates a link between the terrain and the data that's used to create it. And there's two options here. You have dynamic and static. Dynamic terrain models automatically update whenever something is changed, a dependent element is modified. And static, the terrain model has a link to the data, but it doesn't update automatically when that data is changed. It has to be manually updated. And your surveyors, they have this option when they bring in data to have it automatically generate the terrain dynamically, or they can bring in survey data and not build the terrain. And then, after they've massaged their survey data or made any adjustments, then they would do create the terrain, and that's in the static mode. So the rules. Static rules are imported from file, ASCII import, graphical filters, point clouds, and text. The advantage of this is you get to decide when you want to update it, and it overcomes overhead for large amounts of rules. And the one disadvantage is that change management notification. So if something changes, it doesn't update automatically. And here we'll just go through and show you how import land XML. So we're in the 3D file here, and we go to the import option here. Select our XML data. We'll just have a quick look at that first, and I'm sure most of you guys are familiar with XML files, but here you can see the point elevations and coordinate values. Those are like north and east in elevation. You'll see if it's got any feature types like boundaries or void areas, that kind of stuff built into it. So all of that, and there you can see break lines. So when somebody exports a terrain to an XML file, this is kind of what it creates. And being a schema, all civil products can read this data in. So it's just it's a very consistent schema that all civil products can read. And once we select that guy, we can just click the done button, and it's going to bring us back to the dialog to make our settings. Now it read it. It knows it's an XML file, so our file options change just a little bit. But there you'll see the source and definition option for how to build the terrain. You got your three options there: definition, source, and source and definition. And we'll do both of them here, and you can kind of see a little bit of the difference. So we'll just change this name here to definition for this existing file, so we'll know which one it is. Go ahead and import that guy. and then you can kind of see what we get. Just a basic terrain, but it's just the triangles that have been triangulated. So it reproduced the triangles that were in the source data or the definition for it. So now if we go back and we're going to change this one, just import this one using the source. So this is going to kind of include everything. So, you know, the break lines and that kind of stuff are all going to be included. It's not just duplicating triangles. And we'll just change this a little bit so that you can see the difference. Go ahead and import this guy. And there you can see it's a little different than just doing the triangles. And of course, we've got those long ones. Probably need to change the edge method here, maybe 50 feet. See if they'll tighten it up a little bit. But you can see how it doesn't directly overlay the triangles that were created before. So just two different ways. You have a choice when you bring it in. And of course, if you used the source and definition, you would get a combination of the two.
Hey, we just lost audio.
Okay, you got me now?
Yeah.
All right, so now we're going to go back here and take a look at this. Still XML. And we're going to, I think in this one, we're going to do both. Or still just a definition. And so, and what we're looking at here is if we have let's say we had a change, or you need to, let's say they went back out in the field and updated that that terrain with extra data. Here we're going to have a look. You see that there is an option down here, the circle, it says update from source. So this makes it pretty easy. Remember that it has a connection to the source that it was created from. So if that file ever got updated or changed in any way, then it's just easy now. Instead of importing, you can just go to this option and tell it to update it from the source data. So in this case, they maybe extended the survey a little bit. We're going to go back and we're just going to update from source, pick the file there that it was created from. And all it does is it essentially just goes back, looks at the source data, and incorporates any changes that might have occurred. So in this case, we just had an extension of it. So one benefit there from using Land XML, and again, that's a transfer schema, so a data transfer. So if you're getting you know, information from another source, surveyor, or you know, just another company altogether, you may choose to use that particular schema or method. So now we're going to look at terrain and geometry from MX Road. I'm not sure you guys probably deal with this very much. MX popular overseas, but we'll just take a quick look at this. Very similar. The Genio files are ASCII. And then just, there's an example of it there. It's pretty straightforward. But here we'll take a we'll just have a quick look here, bringing in what's called a FIL file. And we just, again, it's very similar to bringing in the data that we did from InRoads and GEOPAK. Just want to make sure that we have again, an existing 3D file. This is going to be terrain information. So we just want to let that file open. Go back to the terrain tab. Use the from file option again. And we want the model file. And this looks just a little bit different because they store their information a little differently. So you'll see we've got different options up here. You've got design, survey, sections, triangles, all kinds of stuff in here. So it's a matter of just selecting what you wanted. In this case, we just want the terrain data out of that file. It essentially holds all of the project data for an MX project. So we're just going to select the terrain imports or the terrain information, set our feature definition, and then import it. And there you see we've just taken that data and created a OpenRoads Designer terrain. So at this point, it acts just the same as everything else does. You have your quick properties, got all of your options for manipulating how it's displayed, can change feature definitions, do anything just like you would any other OpenRoads terrain. So now we'll look at bringing in the geometry from an MX project. And this is going to require that we have a 2D file. So again, we just create the 2D file. Go to the geometry tab, use the import option. And we're looking now for the Genio files. Or I'm sorry, this one's coming out of the FIL file as well. And here you'll see there's a little, again, because they store their information differently in this file, or they store a lot of information in it, we have to look at what we want to pull out of here. So in this case, we want the alignment. So we just go up here to this option and we'll see there's an alignment there with a profile. We turn on the create civil rules and import that geometry. And again, it comes in non-featurized, so your workflow is the same. You would go through, select that guy, just set a feature definition on it. Likewise with the profile, you would do the same. It's just a matter of going to the quick properties and making that setting. Pop the dynamic profile view open. Once again, just go to the quick properties there. Slide that over on the screen a little bit. And set it for the profile. So pretty easy to get that kind of information in, regardless of what software packages that you're dealing with. So now, in this case, we're going to go back, get us a 3D file. To bring in a terrain. And in this case, we'll look at the GEO files. And just a little bit different here, you'll see how there's options for filtering this. But again, you have the feature definition, triangle options, and your GCS. So we just selected the terrain that we want to bring in. And then select the import button. Bring that data in. And again, now it's just a OpenRoads terrain. Last one here we're going to look at is 12D data. Doubt you guys probably run into much of this. It's a Australian, Africa, Asia type product on that side of the world. It's an interactive graphic program. It has survey data, terrains, conceptual and detailed design models. Just contains a lot of information. But we'll just take a quick look here at how to bring that in. So let's see. We're in a 3D file here for our existing terrain. And here you see that this is an XML file. So again, it's just a matter of selecting that file, giving it a feature definition, and doing the import. And then here we're just going to get into a file for geometry. Take a quick look at that. Same type of deal, just go select the file using the import option. Here you'll see it looks it's just a little bit different information because they put a whole bunch of stuff in there in that model file. But it would just be a matter of selecting the alignments and such that you want and importing those. And of course, then you got the same situation there. You don't have the workflow would be to go back now and set the feature definition on it once it has it imported. And again, that's just a matter of going to the same tools, your heads up display, quick properties, setting the feature definition. And letting it take on that symbology information that's associated with that particular feature definition. Oh, we got one more, last one, International Foundation classes. So what this is, IFC, and you may or may not run into this, it's becoming a little more popular, especially as everything's going 3D, and their 3D models is, you know, the way of the future. It's again an exchange type file, an open BIM data exchange. It is a schema, and it's just kind of a snapshot of your model. And you can't edit it, but you can view, measure, do clash detection, cost estimation, different things like that. So especially with regards to bridges and Open Bridge Modeler, and we get into some of those, even with our models, we can create this IFC content. So just give you a little quick demonstration of that one, bringing it in. You're going to see in this case, this is kind of a site design. It's a rail station. So it's kind of got the structure for everything for that rail station in it. And then the IFC model was created, you know, using the export. And then what we did here is you can just bring it right into OpenRoads Designer. Now this one goes through the backstage. You've heard us talk about the backstage here. And if we go down here to import, you'll see here there's options for data file types. So if you go under the exchange file type, you'll see an IFC option right there that you can select. And then once you selected that, it brings that model in and essentially just reconstructs it here in OpenRoads Designer. And again, you can use it for, you know, clash detection, measuring quantities, that kind of stuff. Just like, you know, any other 3D model. You can't make edits to it though. It's just kind of like I said, it's kind of a snapshot, a one-time deal. But it could prove useful, you know, for doing conflicts and stuff. All right, used up most of the time there, but I think that just about does us. Want to thank everybody for coming.
Thanks, Chris. Just a reminder, we'll send out the PDHs later on this week. If you don't get one and you were expecting one, make sure you reach out to events@nclug.com. Next week on August 6th, we'll be having NCDOT present pretty much OpenRoads Designer update. So pretty much where they're at, how they're looking at in the future, and where they're taking the implementation of OpenRoads for NCDOT. So make sure you sign up for that. I will be sending out an email shortly for that, or you can go on our website to sign up for that. Make sure, if you're not a member yet, definitely jump on the website and become a member so you can get all those emails and stay up to date with upcoming events. I think Patty has a $50 Amazon card winner.
Yep, our winner is Diana Dedmore. We'll be sending an email to you with more, you know, information about your gift card.
All right. Well, I think we have a couple of seconds left. Does anybody have a question for Chris?
This is Patty. I just had a quick question. I know in the past there's big issues importing like Autodesk products. I know that's probably a whole nother series of power presentation, but is there a lot of more headway in as far as importing DWG files?
Yeah, so you're wanting to import those? You know, you can open and work in DWG
Okay. Yeah.
directly. But typically in your import, you're going to use DXF and things like that. If you have civil information coming from Civil 3D, probably Land XML is your best option. There were issues a long time ago, Patty. I haven't, I think it's much better than it has been, but I'm not 100% at where it stands right now.
Alrighty, unless anyone else has a question, we can call this one adjourned. Appreciate it, Chris, for your presentation, and thanks everybody for attending.
Sure, no problem. Thank you, guys.